Hi guys. We are going to start a new lesson today. That is Edexcel IGCSE Physics Unit 2. So this unit, it's all about electricity. Right. So we're going to learn all about electricity in Unit 2. So we take the first lesson. First lesson is main electricity. This is the first lesson we're going to learn, mains electricity. Okay, now before we're going to learn the electricity, we need to know one or two things, because these two things are very important to understand many concepts in electricity. So the first thing is current. So this current, abbreviated by capital I. So probably will be wondering why not C, it's I, because it's originally originated from French. That is a kind of a word they try to explain the intensity of the current. Could be pronounced as intensity de current. So I'm not sure about how this pronunciation, but the intensity of the current is given for this current word, right? So now it's the current is the rate of the flow of charges, right? So the definition is it's a rate of the flow of charges, rate of the flow of charges. So what are charges? So charges could be atoms, ions, electrons, something like that. So basically common charges in electricity is the electrons, right? But we don't, in definition, we don't write electrons, because it's very specific if we write electrons. So then we have to write the charges. So that's a rate of the flow of charges is the current. And units, it's ampere. Unit is ampere, and the abbreviation is capital A. Sometimes this is also abbreviated as amp. So ampere is also abbreviated as amp, and we write is capital I. So that's the first thing we should learn. So then the next thing is the voltage. Voltage is written as capital V, right? So voltage is written as a capital V, and it is defined as the energy transferred per unit charge. Energy transferred per unit charge. So the units we measure, it's again you have a unit. Unit is watt. Watts. Capital V is now its energy transferred per unit charge. So basically we can understand this both concept. the current and voltage. The current is a flow of charges. Just consider the tap and the pipe. So when you open the tap, the water starts to flow. Consider water as electrons and the pipe as the medium, and voltage is the pressure difference between one point to another point. So if the higher the pressure, the water flow is higher. Lower the pressure, water flow is low. So same way, voltage is higher, then more current pass per unit time. So we consider as energy transferred per unit charge. So then the charge 1 unit, the energy, what is the energy transfer per unit charge is the voltage, or basically we can consider it as the pressure of the electrons when it flow in a medium, right? So that's a main thing we should understand under the first lesson is the mains electricity. So this is the rate of flow of charge is the current, and the energy transferred per unit charge is the definition for voltage, right? So that's a very important thing to remember before we proceed to the lessons, right? Okay, now next we're going to learn what is this mains electricity. Okay, it's very simple to understand. The mains electricity is, so we have a house here, and we have here the power station. Right? So this is the house, and that's a power station. Now in power station, they can generate electricity in the different methods. So we are not going to learn what are the different methods they're going to use. Mostly it could be the fuel, coal burning, or it could be a hydroelectric power, or maybe wind power, or maybe a nuclear power. So there are many sources available to generate the electricity. So once they generate the electricity, then this electricity supply through the wires to the house, right? So what we get from this wire is the mains electricity, right? So that's called mains electricity. The mains electricity is the one that we get from the power station to household. Now this electricity is known as alternative current. Alternative current. So alternating current, or AC, right? So AC current, alternating current. So the alternating current is the one coming from power station to house. And why we call alternating current? So as we learned, the current is a flow of electrons. Then there are two ways of flow of electrons. One is, so electron flow like this, one direction, and again it go backward. So it goes like this. So electron move like it's the cycle, like it's just like the flow of electrons, alternating current, one which is constantly changing the current flow in one direction and then in the opposite directions. So it just go this direction and then opposite direction, this direction, opposite direction, this direction, opposite direction, this direction, opposite direction. So it's alternatively changed the direction. That's called alternative current. And the other one is called direct current. That's also called DC current. DC current, the flow of electron is always one direction. Right? So I hope you understand now. Alternative current, it just changed the direction each time like this, and it's moving. The direct current, it just move like this, always one direction. So we get from the mains electricity as an alternative current, and this one, the voltage of this is usually 230 watt. So that's the voltage, 230 watt. Right, this voltage is quite high voltage. So let's think about what is the lowest voltage we can experience. 1.5 watts from the battery. Usual batteries, they have 1.5 watts. But what we get as AC current from the mains electricity is 230 watts. So usually this voltage good enough to kill a person, because this electricity enter into the human body, then it can change the conductivity of the heart, muscles, could be even affect the brains like places, and within a short time these organs get failure and the person can die. So that's a very important thing to consider, the danger and safety of this mains electricity, right? So the alternative current and DC current and AC current, so we get alternative current from the system, right? So then we're going to see how this electricity comes from the power station and how we distribute in the house, right? So let's move into the next part. One, two, three. Okay, now we get the electricity from the main line, the grid, or directly from power station as a one wire. So usually this wire is a copper metal and which is insulated with rubber. Those are the wires we use, the copper metal insulated with the rubber coat, right? So that's called live because it carries 230 watt the electricity to the house. At the same time, the other wire is coming. So this wire, it's called neutral. Usually it has no voltage, so I write as a 0 voltage, and it does not carry a current. And this live wire is a brown color, and this is a blue color. So it's easily we can identify. That's also one kind of a safety thing, that the color code of these wires are standard and we can identify which one is a live wire. Right now, when it comes to the house, so what actually it does, so I just show you something. So let's say we use electricity for various purposes such as light, and also to use the electrical appliances. So we can use electricity to operate the electrical appliances such as the heaters, kettles, the washing machine, air conditioners, computers, phones, many electronic devices. We need electricity. Right now, if the electricity come to this place, so that's a live one, and it should be connected to the neutral one in order to flow the electricity. Right now you see, so this one now complete the circuit. When it complete the circuit, we can use the electricity here for our purpose to operate this machine. And there is another, the wire is attached. So this wire usually attached to the, that's called, let's say this is the washing machine. So then we have another wire. This wire is attached to the metal cover of the washing machine, and this also finally going to the circuit. And this one, what we do, we just use a copper rod which is buried in the garden, and then this is connected to the metal cover of this washing machine. Now that one is called earth wire. So earth wire is it also has a color code. The earth one is, it is a brown and yellow. It's a brown and yellow, and this is connected to the metal cover of the washing machine, and that goes to the copper rod which is buried inside this in the gardens, right? So that is a this one is brown, blue, that's a earth is green and yellow strips, the green color with the yellow strips. So that's a earth, right? So why we need earth, we're going to consider later, right? Now in this way we can complete the circuit, and we can use this energy of this electricity to operate the washing machine, right? So that's called 3-core wires. So then classic example is if we connect this using a plug, and this plug has 3 wires, live, neutral and the earth. So then we connect to our circuit live, neutral and earth, and this connect to the washing machine. So finally the earth wire, which is actually operating inside our house, right? That means the earth is not coming from the mains electricity, only live and the neutral electricity, the wires coming from the main electricity. So the earth wire is only operating inside our garden and the house. So why is that? Because it is a safety precaution. We're going to learn how it works in the next coming up lesson, right? Okay, this also explains how the wires connected from the power station to our house as a mains electricity, and how we use this electricity we're going to learn in the next lesson. Okay, now in this part we're going to learn how this mains electricity bring the energy to our system, and how we're going to use this energy in our electrical appliances, right? So then the power the power of this electricity is abbreviated by capital P. So then the power we can calculate by multiplying the current with the voltage. So P is the power, I is the current, V is the voltage, right? So then the power, the unit is watt. So we measure the unit as watt and adds a capital W. Okay, for example, so the kettle, let's say like this. So that's it's like this. So let's consider this as a kettle, and there is a coil here. So when this connected to the electricity, the electricity passes through this coil, and the coil has a kind of it's very difficulty fast electricity from this coil. We call it resistant. So then electricity, the flow of electrons try to pass through this coil with lot of effort, which resulted heat. And the heat is used to boil the water. So the power of this kettle is 2000 watt. And we connected to the main supply, that is the voltage is 220 watts. Right? So that's a power 2000 watt. Now so we're going to calculate the current of this device, right? So what is the current? It passes from this device. What is the amount of current which passes from this kettle? So we can calculate it like this. So P equal I multiplied by V. So if we want to bring I into one side, so we divide this side by V, and this get cancel, and that come here. So then I can rearrange the formula like this. So power is 2000 watt, and 220 volt is the voltage. So then 2000 divided by 220, so I just write it approximately. So it's approximately 9 ampere. It's approximately 9 ampere is the power of this electric the current pass through this kettle is 9 ampere. So that's about the power, and in the next session we're going to discuss the energy of the electricity. So let's go to the next lesson now. Energy. So as you know, energy is a very common thing in science. Then energy we use in joules. So we use energy in joules. Now the energy we can calculate by multiplying the power with the time, right? So that is, the power is a watt, and unit for time is we use second, and that's a joule. So this formula we use to calculate the energy which used by the electrical devices by multiplying by power, which calculate with the time. So let's calculate this. The hair dryer, which use 48,000 joules. Use 48,000 joules in 1 minute. So that's energy. So now calculate the power. So again we do like this. V equal P multiplied by T, and the power we have to calculate, then we have to isolate power. So then I divide both sides by T. So then P equal E divided by T. So energy is 48,000 joules. Time is 1 minute. So 1 minute is 60 seconds. 60 seconds. Right? So then I'm going to calculate this. 6 times 8, 800. So it's 800 joules per second. The rate, calculate the power rate, right? So when we divide by time, it's a power rate. So we calculate the power rate, which is 800 joules per second. Okay, so in this lesson, we learn about the current, voltage, mains electricity, alternative current, DC current, direct current, and the power and the energy of the electricity. In the next lesson, we are going to discuss the danger and safety precautions that we can use in the mains electricity. So please join for the next lesson. If you like this video, please subscribe and just give me a like to this video.